So I'm going to explain one more feedback, which is VFD desired frequency attained. Alright. Now what happens many times in an application of drive, what we want when there is a certain frequency which we have attained from the drive here. This is the edge. When certain frequency has reached, suppose we want to actuate another motor at 20 Hertz or another solenoid or alarm or anything at certain frequency, which is not the final frequency. VFD is increasing, it's increasing. So for example, if I run the motor here, right now it's 7 Hertz. I want, if my motor reach 15 Hertz, I need to have a feedback because I'm going beyond. So to have a feedback at 15 Hertz, we use this function of the motor, VFD desired frequency attained, and we get a feedback from the relay. Alright, so desired frequency attained parameter is over here, parameter 47. That should be assigned the frequency where you want a feedback signal. So in 47 I'm going to enter 15 Hertz. Alright, so this is 46, 47, it's by default 20, let's move it to 15 Hertz. Alright, now the motor is at 9 Hertz. Okay, when I run this drive, it's 9 Hertz. If you see the PLC, this is X6, this is normally closed. X5 will be on when the frequency, which should be H, increases beyond 15. Oh, hold on, I forgot one point. After putting the desired frequency in feedback terminal, we have to put 08. It was 07, my bad. So in 46 we have to enter 08. 46 08. Now you'll get a feedback. So is it at 5 Hertz? If I move it beyond 11, 12, 13, at 15 you have seen X5 is on, and beyond it will remain on. If you go back to approximately 12 Hertz, it will roll back to X6, and at 15 it will run again. So if you want to see precisely, 14.8 it's not on, at 15 it gets on. So this was the feedback of desired frequency attained. Alright, so maybe you don't want your drive to run beyond desired frequency, so you can control your drive in that case. Alright, so that was about VFD desired frequency attained feedback terminal. And you can make an application. Suppose you want that when VFD achieve this frequency, you have the signal X6 in your PLC, alright, and you want something to blink. Let me show you. If I write here LDX6 DM1013, which is my default on-off pulse, and I can take out Y, let's say Y5. Okay, now I'm indicating this desired frequency by blinking. Let's go to online again. Now you can see when I run the drive, hold on, I have to take X5 here, my bad again. It's X5, X6 is NC. Okay, so let's go beyond. Oh, this is going to 19 because my M5 is tuned to external frequency. Hold on, M5 has been assigned a terminal. M5, I should put it to no function. So parameter 42 is conflicting in my case because my out 5 is Y5 is M5. Alright, so let me just put M5 to no functions. So in parameter 42, it's by default 08, which was actually taking the third frequency command. That's why it's going to 19 Hertz. Let me go back to 00. Now have a look. Right now frequency is 10 Hertz. This is the PLC program, and that's the. Now at 10 Hertz nothing is happening. Okay, this is blinking because this is a by default function of the PLC bit, 1 second clock pulse. Okay, when I move beyond 15 Hertz, you have Wi-Fi is blinking. This can be your indication which says yes, desired frequency has been achieved. When I go back below 15, that blinking is off. Alright, so it's your logical skills of PLC how you use this feedback in one or the other way. Alright, well, that was about feedback for desired frequency attained. Alright, so next videos we'll be doing some VFD biasing exercise. Alright, thank you.